Okay, so today what we are going to do is talk about absolute value functions. And the idea is the equation of an absolute value is y equals the absolute value of x. This graph happens to be in the shape of a V. Okay, so we're looking for the shape of a V. Let's make this kind of a little bit bigger. And maybe we'll change this color real fast. So it's going to be in the shape of a V. All right, and then also what's going to happen is the turning point of the graph, just like it was before with parabolas, the turning point here happens to be called the vertex. Okay, so this is pretty much just like what we did with quadratics with the parabolas, but now we're dealing with absolute values. What's kind of cool about this though, in the word absolute value, well, there is a V. That's why your shape is a V, and that's pretty cool. So in order to find the absolute value, you need to be able to use your calculator. And on the calculator, when you try to find the absolute value of something, what you need to do is go to your math button. And under math, if you arrow over to number, that first thing that you see is the absolute value. So for example, the absolute value of -5, hopefully you all know this, should be 5, right? Because the absolute value is the distance a number is from 0. Or let's say we want to go for the absolute value of 20. Math number, absolute value 20, and what should come out is also 20, because 20 is 20 units away from 0. So in terms of what you're going to do on the calculator, is to get to your calc, what you're going to do here is you're going to go to math, and then you're going to arrow over to number, and then you're going to arrow over to absolute value. Okay, so let's actually start doing some stuff with the graph. So the idea is we need to graph each function after completing the table of values. We need to state what the vertex is of each, and then we're going to answer any questions that follow towards the end. So the first one, your vertex should always be that center point. Okay, it should always be that turning point down here. The absolute value of 0 is just 0. As you start plugging in the other values, the absolute value of -2 is +2. The absolute value of -1 is 1. The absolute value of +1 is 1. The absolute value of +2 is 2. So just like you have a pattern in your table, your XY table, for quadratics, you've got the same thing with your absolute values. So -2, 2 is here, -1, 1, 0, 0, 1, 1, 2, 2. Don't draw a U, draw a V. Arrows on either end. Your vertex is centered at the origin. So let's see what happens when we now put some value inside the absolute value chart, the absolute value of x minus 2. So the absolute value of x minus 2 basically says if I plug in 0 minus 2, which -2 comes in, out of the absolute value comes a +2. If I take x to be 1 and I do 1 minus 2 inside the absolute values, that's the absolute value of -1, which is 1. If I now put in 2 into the x value, absolute value of 2 minus 2 is 0, which is just 0. If I now put in a 3 for my x, what's in the absolute value is 1. What comes out of the absolute value is still 1. And if we put in a 4, what stays in the absolute value is a 2. What comes out of the absolute value is a 2. Once again, your vertex is that turning point. It's what's centered inside your chart. And now the vertex did not stay at 0, 0. It actually shifted over to 2, 0. And then we had +1, 1, 0, 2, +3, 1, and then 4, 2. We still have a V. So a number that was inside the absolute value bars, we shifted to the right. Let's take a look at the next example. Again, I'm not going to, well, this time I'm not going to write everything down. I'm just going to kind of do the math out loud. So the absolute value of -2 is +2, and 2 minus 1 is 1. The absolute value of -1 is 1. 1 minus 1 is 0. The absolute value of 0 is 0. 0 take away 1, -1. The absolute value of 1 is 1. 1 minus 1 is 0. The absolute value of 2 is 2. 2 minus 1 is 1. Again, we are centered around that center piece, that vertex. So -2 goes up 1. -1 stays at 0. +0 goes down 1. Over 1 stays at 0. Over 2 goes up 1. Again, it's a V, not a U. Your vertex is 0, -1. So the question says, well, how does the graph in exercise 2 compare with the graph from exercise 1? Well, if you look at graph in 2 and graph in 1, graph in 1, you're centered at the origin. Graph in 2, we shifted 2 to the right. If we look at exercise 3 compared to exercise 1, graph in 1, vertex centered at 0. Graph in 3, vertex shifted down 1. So we're talking about some shifts here. So the vertex shifted two places to the right. That was from 1 to 2. The vertex shifted one place down. And that was from 1 to 3. Well, let's see what happens when we do some stuff with multiplying. So here, again, I'm just going to do the math. Hopefully you can be able to follow along. The absolute value of -2 is 2. 2 times 3 is 6. The absolute value of -1 is 1. 3 times 1 is 1. The absolute value of 0 is 0. 3 times 0 is 0. Absolute value of 1 is 1. 3 times 1 is 3. Absolute value of 2 is 2. 2 times 3 is 6. So we've got -2, 6, -1, 3, 0, 0. 1, 3, 2, 6. This particular V got more narrow when we multiplied it by something. The vertex went back to the origin. Let's try this next one. -1/2 absolute value of x. So the absolute value of -4 is +4. -1/2 times +4, -2. The absolute value of -2 is +2. -1/2 times +2, -1. The absolute value of 0 is 0. Anything times 0 is 0. The absolute value of 2 is 2. -1/2 times 2, -1. Absolute value of 4 is 4. -1/2 times 4, -2. What happens now? We've got -4, -2, -2, -1, 0, 0, 2, -1, 4, -2. So this V turned upside down and got wider. Its vertex, however, was still centered at 0, 0. So how does graph 4 compare with 1? Well, graph 4 is more narrow. The graph of number 4 is more narrow. And then the graph of number 5 flipped upside down and is wider. Flipped, or opened down, I should say, not necessarily flipped, but that's fine. The graph of number 5 opened down and is wider. Well, all of these things happen to be shifts and things that you can actually look at the equations to figure out what's going to happen. So here's sort of like a cheat sheet of how to figure that out. We don't do a ton of this stuff in the Algebra 1, but you should sort of get a sense of what's happening as you move forward. But the graph of an absolute value is always going to be a V-shaped graph. Any constant number being added or subtracted inside the absolute value sign shifts the vertex to the left or to the right. The shift is opposite of the sign in the absolute value. I'm going to bring you back to graph 2 for a second. Oops, wrong way. So here's graph 2. Well, graph 1, we're at 0, 0. Graph 2, when we put a number inside the absolute value, right, x minus 2, well, our vertex shifted 2 to the right. So what we just had on the conclusion said that as long as you've got a number inside the absolute value, you're going to shift left or right, and the opposite sign of what you would think. That's why x minus 2 actually shifts right. Okay, let's go back to our conclusion stuff. any constant number being added or subtracted outside the absolute value, sign shifts the vertex up or down. This shift is the same as that sign. So let's go back to 3. So if you look at 3, the fact that this number is being subtracted outside the absolute value, our vertex shifted down. Okay, let's go back to conclusions. When a number is being multiplied to the absolute value, it changes the width of the graph. A number greater than 1 makes the graph more narrow. A fraction makes the graph wider. A negative number makes the graph open down. So what I tend to say is numbers make you narrow, fractions make you fatter. Okay? Not necessarily politically correct, but it might be a good way to remember. So let's kind of go back here for 1 second. So graph 3, the fact that we were multiplying this thing by a number, the number was greater than 1, the graph got more narrow. If we look at this one, the fact that it was a negative, we opened down, and the fact that it was a fraction, we were wider than the other. So this one looks a lot wider, this one looks a lot more narrow. Okay, so the idea is you should kind of have an idea of how these graphs actually work, the absolute value graphs, but you can always plug everything into your calculator. I do want to kind of show you how to do that. So let's just kind of go to the calculator real fast. If you get yourself into y equals, and you want to do the absolute value of x, you'd have to go y equals math, number, enter, plug in the xt theta button, close up your parentheses, hit your graph. I'm going to stay there. I'm going to go back to y equals. I'm going to keep that one in there. Number 2 was math, number, absolute value, x, take away 2. Close it up. This is that shift to the right. Go back in there. Go to graph number 3, which we know was the absolute value. So math, number, absolute value, x, close up your parenthesis, and then we subtracted 1 from it. Watch this thing shift down. If we go into y4, the 4th graph, which was going to be 3 times math, number, absolute value of x, watch how this thing stays at 0, 0, but gets wider. And then if we go to y equals for the 5th one, we did negative 1/2 math, number, absolute value of x. And remember, this is the guy that flipped upside down and got fatter. Okay, so there you go. Good luck on the homework.